Okay. See how things work today. A little better. Yesterday I gave a few examples of what seemed to me to be properly described as non-naturalist, dualist, meaning methodologically dualist, approaches to substantive issues, issues of fact, issues about the world. Let me stress again what you know, but I want to make clear that the advocates of the positions that I'm presenting regard themselves as being paradigm examples of naturalist monism, pure, hard-headed naturalist monism. So when I say that it in fact is non-naturalist epistemological dualism, that is a highly controversial statement, and you therefore ought to take it with a good deal of skepticism, since the prevailing view is exactly the opposite, that this is exactly what hard-headed naturalism is. So, for example, if you read any of the expositions of, say, Quine, Roger Gibson's books, or any of the others, it is described as, just as Quine describes it, as the demonstration of what a naturalistic philosophy would be. Philosophy that peels away all confusion and residues of a non-scientific path and just pursues questions of language and mind and reality and so on strictly from a naturalist point of view. It's even called naturalized epistemology and so on. Nevertheless, I'm arguing the opposite, that in fact it's a paradigm example of a new form of dualism, much more irrational than the old form having been incorrect, but nevertheless naturalistic within the framework of the thinking of the natural sciences. Well, the examples that I gave last time had to do with what's called language learning, what I prefer to call language growth, that is the development of language in the mind. And here what was the issue is what Quine calls radical translation. That's a certain paradigm that describes a number of different things. The core thing that it describes is the way the child acquires language. The child acquires language by means of the process of radical translation, so Quine assumes. Radical translation, anyone even sane who thinks about the problem of language acquisition will recognize that the child is presented with certain data, and here's the child, and something is formed in the child's constitution, brain or mind or whatever you want to call it. Quine actually isn't very clear about what is formed here, but it seems that what he has in mind is formal language. That is, a set of well-formed formulas. At least he says that two different theories about what the child has acquired are indistinguishable if they converge in the set of well-formed formulas. So it appears that what he has in mind is that the output of the acquisition process is a set of well-formed formulas. Now that can't really be correct, because you can't have an infinite set in your head. The only thing you can have in your head is a finite characterization of an infinite set. That would be what I was calling an I language, meaning a generative procedure intentionally characterized in terms of the actual form of the algorithm. Okay, and then if you have an I language, the fact of the matter is it does generate a class of expressions, and then it's a further assumption that Quine takes for granted. He doesn't even go this far. He assumes that somehow, he doesn't assume the I language either. I mean, I can't really give an exposition of this because it's incoherent in my opinion. But if you want to make the view coherent, you would have to assume that there is some kind of generative procedure formed which characterizes the let's call it a generative procedure, which characterizes the well-formed formulas. Now, Quine doesn't seem to want to make that move. That is, he regards the question of a generative procedure, what he calls a grammar, as being subject to lethal indeterminacy. That is, there's no question of truth or falsity as to what's the right one. So if there's no question of truth or falsity, obviously it can't be in the child's head, because if it's in the child's head, it's just as real as his arms and legs, let's say. Therefore, if, in fact, the grammar is subject to lethal indeterminacy, it cannot be in the child's head. Therefore, we somehow are going to the class of well-formed formulas without any finite characterization of them. And then we're making guesses about possible finite characterizations. Now, this is all completely incoherent. I'm repeating the words, but they don't mean anything, because you can't have an infinite set in your head. And beyond that, there's the question whether the formal language exists. As far as I know, it doesn't exist anyway. There's no evidence that there is such an object. There's no gap in linguistic theory that's waiting to be filled by the invention of such an object. No one has ever made a proposal as to what such an object would be. So it's pure mystery. But that's somehow the picture. There is a coherent picture, but Quine won't accept it. He thinks there's something definitely wrong with it. The coherent picture is the naturalistic one that I described before. The child gets the data. There's an I language, a generative procedure, but a very specific one. And we'll find out, since it's a real object, it's just as real as the structure of the visual cortex, and we'll use any evidence at all to try to find out what it is. Biological evidence, evidence from other languages, quantum physics, if that turns out to be relevant, anything. Just follow the methods of science, which are completely opportunistic. You look anywhere for evidence. But we're not allowed to do that here, not under the paradigm of radical translation. So the picture is the child goes from data to a class of well-formed formulas, somehow without going through a generative procedure that characterizes them. Now, you can't make any sense out of this. Something is missing. And for years, in my case, for 40 years, I've been asking Quine what's missing, and I never get an answer. And there's nothing in the literature that tells you what the answer is. So that's where it stands. I can't give a more clear characterization than this. And this characterization is not clear. In fact, it is incoherent. But I don't know how to get beyond the incoherence. That's something intrinsic to this approach, as far as I can see. If somebody knows how to do it, I'd like to hear it. But I've never heard it, and I can't find anything in the literature about it. Well, okay, somehow the child goes from the data to the class of signals or well-formed formulas or something like that. Quine recognizes, of course, that unless there's some structure to the child, you won't do anything with data, right? Unless there's some structure to the embryo, the nutrition won't have any effect. Well, what's the structure of the child? Quine simply stipulates the structure of the child. He doesn't regard it as a matter that requires evidence, which is a curious move, because you're talking about something real, the structure of the child. If somebody makes a proposal about the visual system and says, I think it has such and such a property, like I think it determines structure from motion, or I think it has line detectors or whatever, they're expected to give evidence, otherwise nobody pays any attention. You can come up with any crazy idea you like. But in this case, somehow you don't have to give evidence, you just stipulate it. And the stipulations are the ones I mentioned yesterday. There's a quality space. It's a space, which means it has a kind of a metric in it, meaning there are things like, he doesn't say exactly what they are, but presumably the kind of elementary, properties of things like color and size and shape and loudness and so on, and then some measure that tells you how close things are, which allows a degree of generalization, so you generalize from one point to a close point. There is, as Karma pointed out yesterday, conditioning. There's the assent-dissent experiment. The child is allowed one experiment, namely asking, is this a so-and-so? That's the experiment the child's allowed. There's elementary induction, meaning simple induction. So if a thing has happened a lot of times, it'll probably happen again, that kind of thing. And tacitly, this is never discussed, but I discussed it last time. Tacitly, there is some linguistics, and we don't know exactly what, because it's tacit, it's never stated, but it's at least phonology. And apparently also morphology. If you look at, here's a question of interpretation of texts. Now we're talking about something like interpreting Gothic texts or something. You know, you see what's written and you try to figure out what the person has in mind, because it's not stated. And what seems, if you look at the texts, you find presuppositions about morphological structure, you know, inflections and plural and things like that. They seem to come from somewhere, and the child has them. So apparently the child has morphology. The child somehow allowed to pick up words. And I don't know, maybe something about sentences, I'm not sure. But some range of things are given tacitly. We're not told why. You can just see from reading the texts that they're assumed. Well, that's the radical translation paradigm. The next crucial aspect to it is that the linguist is identified with the child. Actually, there's a further point, which I didn't mention yesterday, but I'll talk about now. The person in communication situation, meaning, let's say you and I, when we're talking, is also identified with the child, hence the linguist. So all three of these are the same. All three of them require use of the radical translation paradigm. With regard to the child, the radical translation paradigm is a theory, or would be a theory if it was filled out and if the incoherences were removed. If you could explain what you mean by going to the set of well-formed formulas, and if you could fill in these tacit assumptions, and if you would spell out the quality space and so on and so forth, then you would have a theory of the child, right or wrong. I mean, in fact, so obviously wrong that nobody would even bother, no scientist would even look at it, as is always going to be the case when you simply stipulate a theory. I mean, if I were off the top of my head to stipulate a theory of the visual system, the chances that it would have anything to do with reality would be zero. And the chances that this one has anything to do with reality are also zero. And insofar as it's clear, it's not completely clear, so you can't really test it, but insofar as it's clear, it's just flat wrong in every respect. That's why nobody who, say, works on language acquisition, it's a big field of language acquisition, but nobody pays any attention to this model, because it's so totally wrong in such obvious ways that there's no point in pursuing it. But strikingly, it's arbitrary, it's stipulated. And that itself is a very sharp departure from naturalism. Now, when I say it's arbitrary, I don't mean that it has no historical sources. It does have historical sources, and here we get into a matter of kind of, hermeneutics or something, exegesis, trying to figure out what's in the back of people's minds. And in this case, it's not very obscure. What's in the back of Quine's mind, I suppose, is formal arithmetic, or, formal systems, like, say, arithmetic. If you want to set up a system of arithmetic in the modern period, say 20th century, if you take a course in metamathematics or foundations of mathematics or something like that, you'll start off by defining something called a language, although it has none of the properties of natural language. This is just a metaphor. In fact, it's radically different from natural language in all of its respects, but it's a metaphor. It's called a language, so okay. And the language is formed by picking some symbols, like plus and zero and successor and so on. So you pick a bunch of symbols and you list them and say, here's the symbols of the language. That's the phonology, if you like. And then you have an operation called concatenation, which allows you to string these things together So you can get something like 0, times, let's say you're allowed 3, which is really 0 with a couple of strokes after it, equals, 15, or, left-right parenthesis. I mean, you can string together various symbols. That's a mathematical operation which you can define. And then you give a criterion which picks out a class of well-formed formulas. You say among all these strings, there's a certain infinite class which are well-formed formulas, like 2 plus 3 equals 17 is a well-formed formula, but left parenthesis plus right parenthesis equals 3 or something isn't a well-formed formula. And you give a criterion for that, and that's a mathematical operation. It's like defining a set of even numbers, let's say. And that's your language. This is now the language. And then you can pick one or another generative procedure, any one you feel like, to characterize that infinite set. Like you can pick a particular, system that'll form the things, or you can pick some other one. And indeed, it is indeterminate. It doesn't make any difference which one you pick. You do the same thing within the class of well-formed formulas. You may want to make a further distinction between those that are theorems and those that are not theorems. So this one isn't a theorem. But if I had 5 over here, it would have been a theorem. And you want to make a distinction between those, and then the class of theorems can also be characterized by some procedure, and that procedure is called an axiom system. And again, you can pick it any way you like. As long as it gets the right class of theorems, you can pick it any way you like. And then you can ask very interesting questions. Like, for example, you can give an interpretation of the system under which some of the well-formed formulas are true, and you can ask whether the truths are the same as the theorems. And when you pursue these questions, you reach some quite spectacular mathematical discoveries, some of the great discoveries of modern mathematics. For example, the unformalizability of the notion truth due to Gödel and others. So it's by no means a trivial subject. It's one of the major subjects of modern mathematics with enormous implications, but it runs sort of like that. Now, if that's the model you have in mind, you can sort of understand what Quine's thinking about. Because in that model, it's quite true that you specify the language, so-called, it's in quotes, in metaphoric language, as a class of well-formed formulas. And then you pick the generative procedure, the grammar, any way you feel like, and what are the theorems depends on all sorts of things, beliefs about the world, this and that. And that'll be modified as your beliefs get modified, and there's no, definite set of them. You could pick an axiom system one way, you could pick it another way. Even for systems as simple as arithmetic, it's a remarkable fact that there is no way to give an axiom system that captures our notion of natural number. Any axiom system that you construct is consistent with what are called non-standard models. That is, classes of things which don't have the properties of the natural numbers. So even something as simple as the natural numbers can't really be characterized. You can see why people who know all of this stuff would be led to theories about indeterminacy for something as complicated as language. The trouble is it just has nothing to do with it, it has no relationship at all. It's just, from the very first step, it has no relationship. The structure of formal arithmetic is radically unlike the structure of natural language. And furthermore, these are creations of the mind. Natural language isn't a creation of the mind any more than your arms are a creation of the mind. It's just a form that the brain takes under certain conditions. It's not something you create by thinking about it. This is like a painting, if you like. You just create it. And it's interesting to know how people create things, and then you can ask all kind of questions about what the nature of mathematical truth is, and all kind of interesting topics. But it's a different field. Linguistics, the study of language, is like embryology. It's just the study of how the brain takes a certain form under certain conditions. And any mathematical analogies are just totally irrelevant. It's not even any point pursuing them. The people think there's a formal language in natural language, I suppose, because there is a formal language in the case of arithmetic, and there is because you stipulated it to be so. You stipulated the class of well-formed formulas, Just like, you know, if you're doing number theory, you could stipulate the class of prime numbers. It's the same sort of thing, and therefore it exists because you stipulated it. But you can't stipulate things in the natural world. They're either there or they're not there. You know, you can't say they're there because I say so. That doesn't work studying the natural world. So carrying over these analogies and models is very misleading. Now, remember, what I've just been saying is an interpretation of what I think is in the back of the minds of people who create these systems. They don't say so, but I'm just guessing as to what's in the back of their minds, which could lead to a picture so totally incoherent and so totally arbitrary and stipulative and anti-naturalist. So I'm kind of trying to make up a story that would make it intelligible and understandable that smart people who know mathematics could be so misled when they're studying the natural world. Maybe that's the right story, maybe it's the wrong story. I mean, that's a matter for the biographers. But those are the questions that ought to be raised in intellectual biography if it was ever done by people who aren't just hagiographers, you know, which is rare, you know. Anyhow, that's the picture, whatever the source may be. Now we have to somehow try to make sense out of it, since it doesn't make sense itself. Well, it has various problems. One problem is that the output, class of well-formed formulas, is a completely crazy output. There's no such thing, as far as we know, and there couldn't be such a thing as an output unless there was an explicit, fixed, intentional characterization of it, that is, an I language. And since the existence of the I language is denied, we're in total incoherence. So one, the output of the system is crazy. A second thing that's problematic about the theory of radical translation is that the internal state is crazy. So the output's crazy, the internal state is crazy, not because it couldn't be that way. See, the output couldn't be that way. There couldn't be a possible organism which has that output, namely storing an infinite set without a finite characterization of it. That can't be the case. So the output is just incoherent. The internal structure is not incoherent. You could design an organism which has those properties. That is, it has these properties. It's just that there isn't any such organism around. In fact, none remotely resembling it. What's crazy about the internal state is the idea of stipulating an internal state. The internal state of a complex organism is a very hard thing to understand. You want to understand what makes a chicken embryo turn into a chicken, you got to do a lot of work. You want to understand what causes a human to grow arms and legs and not wings, you have to do a lot of work. And you're not going to have to do less work than that to determine what makes the human brain turn into a human language. So the idea that you can stipulate any of these things is just outlandish. The third thing that's crazy is the identification of the linguist with the child, because their situations are totally different. The linguist coming to investigate the jungle language, as Quine puts it, is not at all in the epistemic situation of the child. The epistemic situation of the child is the child comes already equipped with the innate knowledge of what a possible language is. That's there in the head, somehow. The child comes to the language acquisition problem knowing tacitly that there's a certain class of possible answers, small class of possible answers, in fact, very small. And the child picks out one of those answers, one I language. That's the epistemic problem for the child. The epistemic problem for the linguist is totally different. The linguist is trying to find out what is the epistemic state of the child. That's the linguist's problem. So on the one hand, the linguist does want to find out what the child ends up with, like you want to know what's the structure of Catalan. But the more interesting question, the one that one's really interested in, is what is the structure of language, which is a question about, the question sometimes called universal grammar, which is simply the question, what's the initial state of the child? So the task of the linguist is to discover the epistemic state that the child begins with, to insist that the linguist approach that problem by being in the epistemic state of the child doesn't make any sense. In fact, the linguist, as I say, will use any data at all. The linguist won't be restricted to this data. Why should he be? The linguist will certainly use data from other languages. In fact, every linguist always does that. If somebody's studying Catalan and they have two choices as to how to handle causative constructions, they'll ask questions about how causative constructions work in other languages. This makes perfect sense, because however they work, it's being determined by the internal state, and if you have evidence about it from Japanese, that's going to bear on Catalan, obviously, but that's excluded here. If anything were discovered, say, about, ERPs, say, electrical activity of the brain, a linguist would be happy to use that as evidence. If anything's discovered about the theory of cells, fine, use that, use anything. You're certainly not restricted to this database. And you can't be in the epistemic, and you're not in the epistemic situation of the child. A person inquiring into the nature of the epistemic state isn't in that epistemic state. You're using some other capacities of the mind, the capacities that you use when you try to understand quantum physics. Those are the capacities that you're using when you try to understand this, right? Like when you're trying to figure out quantum physics, you don't use these capacities, even if they existed. In fact, you also don't use the actual capacities of the child. When you're trying to understand quantum physics, you don't use universal grammar or whatever it is. That's just irrelevant. You use whatever the relevant aspects of our science-forming abilities are, and those are the very same aspects that you use in trying to answer the question, what's this epistemic state? So the picture has three forms of craziness, if you like. One, the output, which is incoherent. Two, the input, which is stipulative and wrong. And three, the assumption that the linguist is in the epistemic state of the child, which doesn't make any sense at all. So it seems to me that this entire picture has just nothing in it that can be resurrected. And any conclusions that follow from it are valueless, because it can't get off the ground. Now, very far-reaching conclusions are drawn from this about the theory of meaning and, people and so on and so forth, and it's a highly influential paradigm, but as far as I can see, it's about as remote from naturalism as anything you can imagine, in every respect, completely off base. Let me just finally add the thing that I forgot to mention last time, the identification of the person in the communication situation with the child. The idea is we have two people talking, let's say Peter and Mary, and the question is, how do they proceed to communicate? Well, according to Quinean view, they essentially proceed by radical translation. Okay, that's the only thing they can do. So Peter has that set of qualities, and Mary has that set of qualities, and maybe they're allowed some guess. Maybe they've already achieved some kind of language. That's not clear, It's not stated, so I don't know what to say about that. And then they try to communicate. Peter hears Mary say "gavagai" and tries to figure out whether that's rabbit or rabbit stage. That's the story. Okay. So the person in the communication situation is like the child. Notice again that this is radically different from the way we study any other kind of communication. There are a lot of other communication problems that people study all the time. So there's questions about how cells communicate. They do. So, you have two cells over here, and you want to know how they interact. They do. They interact in all kinds of ways. Well, you never study cellular interaction by stipulating something like a radical translation paradigm and saying that's how it works because I say so. It would be too idiotic to consider. Or suppose you're studying, say, ants, which also communicate chemically, or say bees, which have something which is sometimes called a language, but that's again just a metaphor. Just everything from cells on up has some kind of communication system. In the case of bees, it's called a language, but you could just as well call it that for cells, or ants, or anything else. Or let's say, chimpanzees, or birds, or whatever. There's all kind of work, interesting work in biology that studies communication between systems. And the way it works is always the same. you try to discover what's the internal state of this system. And what is its internal state? And you ask two questions about it. First of all, what is it? And then how did it get there? Okay. So those are the basic questions. You want, if you're studying a communication situation, you want to know what's the internal state of the entity in it, and how did that internal state arise? I mean, that's standard science. And in fact, that's the way you do it for cells, ants, bees, chimps, birds, and so on and so forth. But when we get to humans, we're not allowed to do it anymore. That's the same dualism suddenly arises. When we get to humans, we're not allowed to ask, what's the internal state of Peter? What's the internal state of Mary? How do those internal states affect their interaction? And how did those internal states develop? Right? The questions we would ask about everything else, from the level of cells up to humans, we're not allowed to ask here. Rather, we have to assume that the epistemic state of Susan and of Peter and Mary is what is stipulated by the philosopher. There's nothing in the history of philosophy as irrational as this. I mean, there are a lot of irrational things in the history of philosophy back for thousands of years. You know, people have made stipulations about the natural world, but I can't think of anything as irrational as this. You go back to the earliest period, the stipulations about the natural world were sort of speculations based on current understanding. So, you know, Democritus and Adams was a speculation based on current understanding. I mean, you saw that if you poured oil on water, it didn't extend forever. Okay, so you think, okay, there must be discrete particles or something, which is quite good reasoning, in fact. And in fact, quite generally, concepts, speculations about the world, or say Hume speculated that the springs and origins of human understanding, as he called it, involved certain principles of association and so on. Okay, it's a theory, you know, not unreasonable, wrong, but not unreasonable. But anything, I think you have to look very far to find anything as irrational as this. You might try, but I think it's unique in the history of thought, in fact, in the level of irrationality that it's reached. And strikingly, there is no internal critique of it. People, just very smart people, you know, really smart, sophisticated people, pursue it as if it makes sense, without any serious questions being raised about it. Maybe what I'm saying is completely wrong. You ought to certainly take that possibility very seriously, because it's a very strange thing if it's correct. But if it's correct, you know, it does require explanation. There's another aspect of this, which I mentioned a little bit yesterday, and that is the willingness to, in the case of Gavagai, the willingness to allow, which is the standard example, you know, the one example, the willingness to allow the child, the linguist, and Peter in the communication situation, to allow them to pick out the phonology of the word. They're allowed to pick out the phonology of the word Gavagai. They're not allowed to pick out the meaning of the word rabbit. Rather, there's indeterminacy about the meaning. Well, that's an asymmetry, which requires explanation, because as we know, picking out the phonology is no trivial matter. In fact, it's a sophisticated matter, and in fact, there really is underdetermination, really is. The child's, or the linguist's, first hearing of the signal, you know, even just writing the phonetic transcription of the signal already brings to bear a rich theoretical apparatus based on universal phonetics. But even when we get beyond that, we know perfectly well that what range of variation falls within what we will ultimately call the word Gavagai for a particular language is underdetermined by the first signal, certainly. In fact, it requires building up a pattern and a system and meeting certain formal conditions and so on and so forth. So there are problems there, but somehow we're allowed to get over those, and maybe over the morphological ones and so on. Well, again, no reason is given as to why we're allowed to do those things, but not do what amount to comparable things in the case on the semantic side. On the semantic side, they're supposed to be lethal indeterminacy. There is no truth to the question of whether gavagai means rabbit or rabbit stage, but there is a truth to the question about whether, gavagai and kepeki or something are the same word. There's a truth to that question, but not to the question of the meaning. Well, that requires explanation because they're similar problems. And in fact, we have probably better evidence in the case of rabbit and rabbit stage than in the other case. Well, that question again is not addressed, and we might ask why. And again, we have to just try exegesis. And my guess is the one that I suggested yesterday. There's a tendency as you get closer to the traditional mind, the traditional soul, there's a tendency to veer off into irrationality for whatever reason. So therefore, you kind of presuppose the rational assumption in the case of the phonetics, which is far enough away not to bother anybody. But you're not allowed to presuppose the rational steps when you get closer to the semantics. Now, actually, I say an argument is needed, and in fact, one is given at this point. And it's worth, to be fair, it's worth saying that the argument that's given is the theory of meaning holism. This is a notion that comes in various strengths, how holistic meaning is. The least strength is that, which almost everybody in the field accepts, that the meaning of a word doesn't have meaning in isolation. Okay, a word has meaning only in the context of a sentence. These are the relevant contexts for determining meaning. So a weak version of meaning holism is that only in the context of a sentence does a word have meaning. You first learn sentences, and then you kind of abstract away the meanings. A richer theory is that a word has meaning only in the context of a language. Okay. A still richer theory is that a word has meaning only in the context of what's sometimes called a theory, meaning a total belief system of which the language is a part. Okay. Now, Quine actually, crucially, and one of his crucial ideas is this one, that a language has, or any word has meaning only in the context of a theory. That's the extreme version of meaning holism. And if that could be true, after all, that's a substantive proposal, hence could be true. And if it's true, then it's correct that there would be a distinction between, that if it's true, that would give an argument for the distinction between sound and meaning, because sound is not supposed to be subject to this kind of holism. Well, we might ask, in fact, whether sound is subject, could be subject. Well, let's take a look at the arguments and see if sound could be subject to that kind of holism. So, for example, take there's a recent book on meaning holism, an interesting book by Jerry Fodor, and Ernie Lepore, called Meaning Holism. And they ultimately, they don't actually reject the idea, but the book is a critical analysis of the idea, so they're not advocating it. They're just considering various reasons why it looks plausible and showing problems with those reasons. Okay, that's their purpose, and it's quite an interesting book. They start the book by saying why meaning holism looks so plausible. In fact, they say it looks even obvious, which is hence, setting forth their own project. They say, look, here's this idea which looks totally obvious, but nevertheless we're going to show some problems in it. That's the project. Well, the reason it looks obvious is essentially that story. They say, take a word, like say, take the word bark. Well, obviously, it means something different if I say I peeled the bark off the tree or the dog barked. Okay, so therefore, the meaning of a word is determined by the sentence. Okay, we've shown that. Or take, say, flying planes, another example from the literature that they give. If you put it in the context, is dangerous, it means one thing. If you put it in the context, are dangerous, it means another thing. So therefore, the meaning of a word depends on the sentence. And we've established at least the weak form of meaning holism. What about the stronger form? They say, well, consider the expression. I'll have to write it in some neutral form, so let me write it in English, because we want to be neutral across languages here. I'll write it in English with the quotes around it, meaning abstracting from English. So they say, take the expression Empedocles leaped. Let's put brackets around it to mean we're abstracting that expression from English, And they say, well, that expression, Empedocles, named philosopher, leaped means jumped off a mountain or something. They say, if you take the sentence Empedocles leaped in English, it means the philosopher jumped off the mountain. If you take the sentence Empedocles leaped in German, where you would spell this like this, but they say the same sentence, then it means Empedocles loved somebody. Okay? So therefore, we've shown that the meaning of a word is dependent on the language. Okay? And what about the dependence on a theory? Well, here there are standard arguments given by everybody. People say, look, take the word momentum. At one time, it meant whatever it meant, mass time, whatever it is, mass times acceleration or something. And at a later stage of physics, it was just given a different meaning. In fact, the definition of it in the early stage turns out to be false in the new stage. So that's a radical change in meaning as theory changes. Or take, say, atom. It meant one thing to Democritus, and it meant something else to Dalton, and something else to Niels Bohr, and something else to quantum theory. So the meaning of the word changes as time goes on. So therefore, the meaning of a word is dependent on an entire belief system. That's the argument. Okay. There are various points finessed here, like to say why Empedocles leaped is the same sentence in English and German, but let's forget that. The question is, how strong an argument is this? I mean, could we, for example, give a theory of sound? Then the argument is, well, look, we've shown, see, once you've established meaning holism, then you've essentially said the study of meaning is hopeless. Because if the meaning of a word is going to depend on sentences and languages and whole theories and so on and so forth, then forget it. There's never going to be, it's like a theory of everything. In order to find the meaning of a word, you'll have to know everything. Well, okay, that's the same as saying there's no study. The topic is finished. Now we've demonstrated that there is a real difference between sound and meaning. And that's what lies behind all of this stuff. I mean, the radical translation paradigm and everything else is supposed to sort of give you the rationale for the theory of meaning holism. Well, just try to construct the theory of sound holism and see what that would look like. First of all, notice that what do people mean when they say the word bark has a different meaning in different sentences? What's the word that has a different meaning? Well, presumably by the word, they mean the collection of phonological properties. Okay? They would say that, or maybe the letters or something like that. But the physical, the output side of the word, the signal side of the word, is what they mean by the word. But that's a funny notion of word. I mean, the word bark in English isn't just a bunch of sounds. The word bark in English is a collection of a bunch of sounds and a bunch of meanings. Okay, that's the word bark. There's a, Saussurean connection between the sound and the meaning. And you have no word unless you have the connection. So that a word is what I call a linguistic expression, which is just a collection of properties. Some of them are sound properties. Some of them are meaning properties. Some of them are structural properties, like bark is, either a noun or a verb, let's say, but not an adjective. And all of those are properties. The word is just the collection of all those properties. Now, if you extract the meaning properties, then you can run through this argument and you can get a theory of meaning holism. But just mechanically, we could do it the other way around. We could leave the meaning properties and cut out the sound properties. Now it's harder to talk about it because it's harder to talk about a word without giving a sound, but that's, just a difficulty. So we could spell it, say. And then we could ask whether the, let's call it the non-phonological word bark, meaning bark with all of its properties, but divested of the fact that it begins with a bilabial stop and so on and so forth. Bark divested of the sound properties. We could say, just as we said that bark divested of its meaning properties has different meanings in different sentences, it has a different meaning depending where it is in the sentence or something. We can say that non-phonological bark has a different sound depending where it's placed in the sentence, which is quite true. If you say the word bark in the beginning of a sentence, you say it differently from the way you say it at the end of a sentence. So therefore the sound of bark depends on where it is in a sentence. Okay. Thinking of bark now as just the thing divorced from its phonetics. Similarly, Empedocles leaped. If we take this expression, now we have to pick one language, so let's pick English. If we take the entire conceptual structure of the philosopher, jumped off the mountain, and we divorce it from the sound part, we can say that Empedocles leaped sounds one way in English and sounds a different way in Catalan. Okay, so therefore the sound of Empedocles leaped depends on the language. Okay. And in fact, we could probably go up to theories if we like. So we've got a theory of sound holism. The sound of a word depends at least on the entire language, which means it's completely hopeless to study sound. We can throw away phonology. There's no hope any longer in carrying out phonological investigation, because in order to study the sound of a word, we have to know the whole language. That's the same argument. Well, obviously that's absurd. And the argument is no better in the other case. So we have no argument for meaning holism, which doesn't mean it's false. Like, maybe it's true, but at least that line of argument won't work, because the very same line of the argument is based crucially on taking a word to be a collection of properties minus the meaning. And if you do that, you can establish meaning holism. If you take the collection of properties minus the sound, you can establish sound holism in the same fashion. But that's just, a trick. And since we don't take the sound holism property seriously and conclude that phonology is a hopeless subject, because you have to know the whole language or maybe even the whole theory before you study the sound of a single word, there's no reason to take the meaning holism theory seriously, at least on those grounds. Now again, that doesn't mean it's false. The fact that an argument given for it doesn't work doesn't mean that it's false. Maybe it's true. What about the last part, that words change meaning as theories change? Well, that's a notion that's extremely hard to state even. I mean, when we say that atom meant one thing for Democritus and something else for Niels Bohr, what exactly are we saying? What is that word, atom, that was shared by Democritus and Niels Bohr? Well, there's no real answer to that. I mean, they're talking different languages. I mean, they put it in different contexts. It's a very mystical notion. This relates to something I mentioned the first day about the free and easy talk that people give about words changing meaning or changing sound and so on. That doesn't really mean anything much. I mean, you can get away with it in normal discourse where precision isn't very important. But when you try to give we're out of normal discourse now, we're trying to give a theoretical account of something. And when you do that, you have to be much more careful about what you're saying. And now you've got to give a sense to the concept, words change meaning or words change sound. And there is no sense to that concept. Now notice there's an interpretation of all of this in I-language terms that makes perfect sense. To say that a word changes meaning over time is to say that if you take successive I-languages, they differ in some, and you draw sort of a line through them at that particular word, you'll find that that element has a different position in the system in different times. You can do that. It's a little bit like saying giraffes evolve longer necks. I mean, we can say that informally, but of course, it doesn't mean that there's a thing giraffe which had a short neck once and has a long neck later. I mean, what it means is the distribution of neck lengths was such and such at one period, and the distribution of neck lengths was some other thing at a different period. That's what we're saying when we say that giraffes evolved longer necks. Now, as long as we're not confused about the matter, there's nothing wrong with saying giraffes evolved longer necks. But if some, say, philosopher came along and said, okay, there's an entity, giraffe, you know, and giraffes used to have short necks, and now giraffes have long necks, and a process called evolution took place between them, that person would be going into outer space, you know. They'd be entering into total confusion. Because all that these are just shorthand ways of saying the distribution of traits changed over time. And that's what's involved when you say a word changes meaning or a word changes sound and so on. If somebody said, ask the question, is a giraffe now the same as what it was, you know, whenever giraffes started a couple millennia ago, that doesn't mean anything. I mean, all we can say is, yeah, there was a bunch of organisms then, and there's a bunch now, and there's a kind of a strange, complicated historical connection between them, and that's the end of the story. There's no question as to whether today's giraffes are some version of earlier giraffes. That's not a question. You know. And similarly, to ask whether Adam for Bohr is the same as Adam for Democritus is just not a question. They spoke different I languages. The I languages matched in certain respects, and we'll find certain similarities between them, and maybe those similarities will be enough so that we'll decide to pick a point in one system and say, okay, it's roughly the same as a point in another system, but that's all you can say. It's like giraffes and necks. Okay. So the entire question is being posed in a way which doesn't make a lot of sense, and is requires a good deal of clarification. And it's clear how to give the clarification, at least in I language terms. But once you give the clarification, the problem dissolves. You know, now there's no longer any question about whether the word the word changed. It's not the same word, you know, any more than Mount Everest is. It's like the question that I mentioned last time. You pick some mountain, and there's an avalanche, and a lot of stuff falls off it, and you ask, is it the same mountain? Well, that's not a meaningful question. You know, it depends on what your interests are. That'll determine whether it's the same mountain or not. It's obviously not the same physical object. If your current concerns as to how to individuate mountains are such that they're similar enough, okay, it's the same mountain. If not, not. But these are questions of decision, not fact. Similarly with the same word. Now, notice that the second point to notice about these examples of the theory holism is that the examples that are given are almost always from natural science. Okay, so it's not the word, let's say, fall that's given. I mean, let's take a sentence that we use in ordinary English. Even one talking about a relatively technical problem. So suppose I say the missile rose from the ground and then fell back to the ground. Okay, we know what that means. Could describe it. That's relatively technical talk already. You know, it's not like John Loves Mary or something like that. Nevertheless, notice that the meaning of the words is not part of natural science. I mean, we know in some other corner of our heads, first of all, there's no such thing in the natural world as the ground. I mean, if you ask a geologist, say, where's the ground? You know, well, you know, that doesn't mean anything. Suppose I actually say, make it even worse, and say the missile rose toward the heavens. And then fell back to the ground. Well, there certainly isn't anything called the heavens. Okay, there's just went up in the air somewhere. So The missile rose toward the heavens and then went down to the ground. There's no heavens and there's no ground. Furthermore, rose is wrong. What we know actually happened is the missile pushed the Earth down a little bit, and the Earth pushed the missile up a little bit, and the missile having much less mass than the Earth, the difference from the initial position is greater from the missile than from the Earth. But they just pushed each other away. And when the missile fell down, all that happened is they pulled each other. The missile pulled the Earth up a little bit, and the Earth pulled the missile down a little bit. And in fact, if you really get fancy, what happened is some geodesic through curved space-time. So that's what happened. But nevertheless, we understand all of this fine. Notice that the words of ordinary English didn't change meaning as theories changed. I mean, there was a time when people would have said it that way, and they would have meant it. They would have meant there's a thing up there called the heavens, and there's a thing down here called the ground, and the missile went up from the ground to the heavens. That's what in fact happened, and then it fell back from the heavens to the ground. That would have been their science. Okay, there was a time when that was science. Right? Now it's not our science. Our theories have changed radically. In the scientific part of our minds, we say, as I say, if we're really fancy, we say something about geodesics and curved space-time, and if we're not quite that fancy, we say that the Earth and the one collection of mass particles and another collection of particles pushed each other apart and then pulled each other back together. Okay, that's it. But the language hasn't changed at all. None of the meanings of the words has changed as theory has changed. And that's quite typical. In contrast, in connection with words like momentum and atom, the meaning has changed. That is, there is no longer any term in scientific language that corresponds to what Democritus meant by atom. Okay. The language of science has no such term anymore. In fact, it has no such term as what Niels Bohr meant by atom, because the theory has changed enough so that notion isn't around anymore. Some other notion is around. We can say that new notion is sort of, a kind of a descendant of the Bohr atom, just as today's giraffe may be a descendant of some earlier giraffe. But that's kind of a metaphoric shorthand for something much more complicated, for something about the comparability of points in two different systems. Well, the point of examples like this is to illustrate that the argument about meaning holism based on change of theory works for natural science if we reinterpret it rationally as meaning we give up certain forms of theory and we adopt new forms of theory, sometimes using the same word, and sometimes with enough match between them. And there's no metric for this, it's just a matter of decision, but enough similarity between them so that we'll say the new atom is a new version of the old atom. Just like we might say that the mountain after the avalanche is the same as the mountain before the avalanche. But there's no substantive meaning to that identification. It's just a shorthand for, helping people know what to look for in the old theory to see where the new theory came from. Okay, it's like the evolution of giraffe necks. On the other hand, for natural language, the theory of meaning holism just seems flat false. And if we look at natural language, we see, in fact, that the terms have retained all of their old meanings as theory has radically changed. And it doesn't matter how sophisticated a physicist you are. You can be the guy who just got the last Nobel Prize, and you'll still say the missile rose from the ground to the heavens and fell back to the earth and mean exactly that. Exactly what you and I mean, because the language hasn't changed at all, even though the theory has changed totally. So insofar as the theory of meaning holism, the big theory of meaning holism, the one that makes meaning theory relative, insofar as that's intended to be a substantive comment about our language, it just isn't true. Insofar as it's a comment about scientific language, it's maybe true, but only in the sense in which giraffes evolved longer necks is true. That is a shorthand way of describing some other thing. Now, these issues arise, I'll if there's time later, I'll come back to it, and certainly the philosophers among you at least will know that these questions arise very crucially in connection with contemporary theories of reference, what are called externalist theories of reference, theories that tell you that the reference of a term, like, say, book or table or something, is determined by the way the world really is. Reference and meaning aren't things in your head, they're things in the world. It's called externalist theories. They're almost universally accepted now. Hilary Putnam is, in fact, one of the originators of these theories. They sort of swept the field in the past 20 years. Putnam, Kripke, and others. Putnam, in talking about the theory, gives the example momentum. He says, look, momentum is a particular thing. They defined it a certain way in the 18th century, and they were just wrong, because they didn't capture that thing. Contemporary physics defines it a different way, and maybe they're right. But there's a thing, momentum, and there's a word, momentum, which refers to that thing. And people who were using the word may have been misreferring all the time. So for Putnam, say, there's a real substantive question as to what Adam meant pre-Dalton, let's say. And he says what it meant is what we mean. It's just they didn't know. Niels Bohr, when he constructed the Bohr model, whenever it was, in 1915 or something, meant by Adam what we mean, even though he misstated its properties. Okay. Now, Putnam argues this on the following grounds. He says, we have to assume this, otherwise we would be forced to say that all of Niels Bohr's statements were false, and all of his beliefs were false. It's as if he was doing astrology, Well, obviously, Niels Bohr wasn't doing astrology. But unless he meant by Adam what we mean by Adam, we can't even interpret his theory in our terms, right? We can't, it's as if he was talking Greek and I'm talking Swahili. I can't interpret it because he doesn't have the same words. So he was just talking gibberish, in other words. And we don't want to say that he was just talking gibberish. Obviously he was talking sense. So therefore we have to conclude that by Adam he meant what we mean by Adam, and some of the things he said about atoms were true and others were false, but that's understandable. Okay, so therefore we have to take this view that says that a word has a fixed meaning determined by the world. Okay, like what a tiger is determined by the nature of the world, and it doesn't matter what concept we have in our mind. Okay, that we're forced to that in order to account for the notion of intelligibility in science. It's basically the argument. Notice that there are a couple of crucial assumptions in that discussion that ought to be brought out and questioned. One is that scientific language is part of language. Assumption one is that talk about electrons and momentum and so on is part of natural language. That is, that there's no fundamental difference between concepts like atom and concepts like house. And that's very dubious, as you can see from the case of the missile rising and falling in the heavens and the earth. I mean, that's natural language. And all the considerations that lead us to consider, that things are really pushing each other apart just don't bear on natural language. That's another part of our minds where we construct sciences. Now, when we construct sciences, we often use the resources of our natural language, because that's what's around, But we're changing it. We're changing them in all sorts of ways. In the natural sciences, we are constructing symbol systems. But those symbol systems can, for example, include calculus, which certainly isn't part of natural language. They can include differential equations, which aren't part of natural language. Furthermore, in that symbol system that we're constructing, we are trying to impose upon it certain properties. For example, one of the things we're trying to impose on this symbol system is the property that there are words, and that these words refer to things, real things, like, atoms, whatever they are. And among those things are what are called natural kinds, meaning, say, liquids. The kinds of nature, the things into which nature is really subdivided. In short, we want to construct this symbolic system so that it has realistic properties. The purpose of the game of science is to construct a symbolic system which will have whatever resources it needs, maybe differential equations, so not language, and will have a relation of reference holding between words and things. It will, and if you discover that the word that the concept that you've proposed doesn't refer to a thing, because there is no thing of that kind, then you change the concept. The natural kinds have to be real kinds. Like, for the ancient scientists, the real kinds were earth, air, fire, and water. Okay, those aren't the real kinds for us any longer. In fact, none of them are. So we've abandoned those. For contemporary science, there are no terms referring to what those guys referred to, because there is no earth. It's not a thing. You know, fire isn't a thing, and so on. We're aiming consciously in science construction to develop a symbol system with realistic properties. Picks out natural kinds, picks out real things. But natural language has none of these properties. In fact, in natural languages, words don't even refer. I think that's just a mistake. I'll come back to that later. It's commonly assumed to be true. But I simply think it's not true that words refer in natural language. That's not the way natural language works. True, people use words to refer, but that's something different. I mean, people use words to lie, but that doesn't mean that words lie. You know, that would be a mistake. The idea that words refer is a big leap, you know. Again, a leap which comes naturally to people who think about the sciences, because in the sciences you're trying to construct words that refer. Also, words in natural language don't have any particular relation to natural kinds. So it's again kind of historically interesting that in discussion of these issues, like in contemporary discussion of these issues, people talk about water, and they say, well, what did, you know, some 16th century person mean by water? Well, what we mean, H2O. They didn't know it, but they meant H2O. It's very interesting that nobody ever picks earth, air, and fire, okay, and say, well, what did they refer to by earth, air, and fire? Now, for the ancients, earth, air, fire, and water were on a par. Why do we give when you read contemporary philosophical literature, say twin earth literature, why do you talk about water and not earth? Well, the reason is obvious. There's a rough counterpart in the natural sciences to our intuitive concept of water, namely H2O. There isn't even a rough counterpart to the other terms, so you don't use those. But the point is, it's only a rough counterpart. There's no reason to believe at all that people in the 18th century, or for that matter, people today, you and me, mean H2O by water. I mean, if we're talking as scientists, we probably mean H2O. But if we're just talking to each other, like if I say, I'm going to drink a glass of water, I'll drink it. I mean, I know perfectly well this isn't H2O. You know, it's got some H2O in it, but it's got an awful lot of other junk in it, you know. And so it's certainly not H2O, whatever it is. But yet we refer to that as a glass of water, not a glass of milk, let's say. And that's correct. I use the word water to refer to this, even though I know perfectly well it's not H2O. The reason why in the contemporary literature you get discussions of water and not earth is that there isn't even any rough counterpart in the case of earth and fire and so on. But the right lesson to draw from all of this is that the symbolic systems constructed by the natural sciences are just unrelated to natural language, just as the formal systems constructed in formal arithmetic are unrelated to the natural languages. Well, unrelated is a strong term. I mean, maybe they're influenced by them in some respects. But to the extent that they're influenced by them, the reflective scientist will regard that as illegitimate and will try to correct for it. I mean, if your symbolic system happens to be influenced by the language you speak, or what's called common sense, and if you happen to notice that, you'll try to overcome it because it shouldn't be. The goal of the scientific language is something else. It's a constructed system aiming at a certain purpose, and the purpose is to capture reality. by having symbols that designate and predicates that have, predicational properties and so on and so forth. Natural language has nothing like that. We can see it very clearly when we take the parts of natural language in which we talk about technical operations, and notice at once that we're not using the words in the scientific sense, even if we happen to be scientists. So there is a substantive theory. I went too fast when I said that Quine had no argument for distinguishing the willingness to accept the form of Gavagai from the unwillingness to accept the meaning of Gavagai. He had an argument. The argument was meaning holism, which can take various forms. The weaker forms, the relativity of meaning to sentence and language, those are insignificant. Those are just misleading tricks. It's the same arguments would give you sound holism, which is confusing no one. It would just tell us that in a particular I language has the property that sounds and meanings are correlated in some specific way, not some other way. If they were correlated in a different way, it would be a different I language. It's a triviality. So there's nothing to meaning holism at the lower levels. With regard to theory holism, the crucial one, the one that Quine's really interested in, it's very hard to state the concept. It's just kind of stated in a hand-waving fashion. When you try to state it, it becomes quite hard. You get into these questions of what it means to have the same word in different languages and so on. Furthermore, it's based on an entirely illegitimate assumption that scientific language is part of natural language. And it's based on a misinterpretation of scientific language, which takes things like giraffes evolved long necks literally, instead of recognizing that they're a shorthand for something else. As to the problem about Niels Bohr and intelligibility, Putnam surely has a point. We don't want a theory of science which leads us to the conclusion that Niels Bohr was doing astrology. Okay, we certainly don't want that. Nevertheless, however interesting a theory of intelligibility in science may be, it's not a basis for a theory of language. It's some other question. And furthermore, as far as I can see, there's a perfectly good I-language and internalist interpretation of the Niels Bohr problem. It makes perfect sense to say all of Niels Bohr's statements were false, literally, but he wasn't doing astrology. Although the statements were literally false, because there were no things such as atoms in his system, so the statements were literally false. Nevertheless, the structure of his theoretical discourse was similar enough to the structure of our theoretical discourse, so we can construct rather natural matches between them. In fact, and having done that, we can even take over a lot of his discoveries, and we can make sense of an awful lot of what he was saying, even though it was all literally false. Now, in the case of astrology, it's quite different. It's literally false, and there's no matches that enable us to make it true. So that accounts on completely internalist grounds, completely internal to the head, for the intelligibility of Niels Bohr, without any strange assumptions about words retaining meaning over time and the ancients having meant H2O by water and so on and so forth. And in fact, that seems to be probably the right way to do it. Let me give a linguistic analogy, which is much simpler, because linguistics isn't as complicated as physics, which illustrates the point. If you go back about, say, 40 years ago, there was a debate in phonology between structuralists and what were called generative phonologists. They had a different conception of what the basic unit was, a phonological unit. The basic unit out of which representations are constructed. According to one or another, say, Jacobsonian structuralism, a phonological unit was a collection of distinctive features, where the features are things that you can perceive. Okay, you can actually get phenomenal correlates to them and acoustic correlates to them. And a phonological unit is a collection of those. Some other linguist might have had some other conception of it. The generative phonologists were saying, no, a phonological unit is an element in an abstract generative system which appears at a certain formal level. It doesn't have features that you can hear. It may ultimately end up with things that have features you can hear, but that's not what it is. Or they were having a debate like the debate between different theories of the atom. Now, let's assume that the debate has been resolved, okay? And let's say, for concreteness, that doesn't matter, that the debate was resolved in favor of these guys, which is what I think. But if you think differently, it's the same story. Make it whatever you like. So for concrete, let's say the generative phonologists were right. Now, does that mean that the structuralist phonologists all along were talking about the units that generative phonologists were talking about? I mean, does it mean that Jakobson was really talking about elements in an abstract level of phonological representation? He thought he was talking about features, but he was mistaken. I mean, if you asked him, he would say, of course not, you know. And he'd be right, he wasn't. He wasn't talking about what nowadays people call phonological units. Was he talking gibberish? No, of course he wasn't talking gibberish. In fact, we can make a lot of sense out of what he was saying, and you can take a lot of it over, and you give some reinterpretations here and there, because there's a close enough match between generative phonology discourse and structuralist theoretical discourse. There's a close enough match so you can carry a lot of it over and reinterpret it and do it in unique ways and illuminating ways. It means the discoveries aren't lost, you know. Maybe everything that was said was literally false, but the discoveries were by no means lost. They just undergo a certain translation into a somewhat different conceptual framework. Now, you know, any linguist looking at this would surely say this was what was going on. They would not say that Jakobson was really talking about contemporary phonological units. And similarly for, you know, like when I was doing phonology 25 years ago, and I referred to something as a phonological unit, it was different from what people mean now. But I wasn't referring to what they mean now. I was referring to what I thought then. It doesn't mean I was doing astrology, you know. Maybe some of it gets translated into modern terms, maybe it doesn't. And there's no special reason why it should be any different in the case of Bohr and the atom, or why we should get into crazy debates about whether, say, before Avogadro, people used the word atom and molecule interchangeably, I think. It seems that they use them to mean the same thing. Well, are we really going to have to say that they meant by atom what we mean by atom, and they meant by molecule what we mean by molecule, even though for them the words were interchangeable? Well, that's what you'd have to say on these theory holist, externalist theories, but it obviously doesn't make any sense. They thought there were small things around out of which the world was constituted, called, indeterminately atoms or molecules, and we don't think that. We think there's two different kinds of things, one of which we call atoms, one of which we call molecules, which are different, and they're kind of descendants of their concept, but descendants only in the way in which a contemporary giraffe is a descendant of an earlier giraffe. Changes have taken place along the way which allow for certain matches, not others. Well, I'll make a last comment about this stuff and then go on to the next topic later. The place where I actually want to come back to this in connection with theories of reference. As you can see from what I'm hinting at, I'm going to want to get back to the conclusion that contemporary theories of reference completely misconstrue language because they're based on a notion that doesn't exist, namely a notion of reference that holds between words and things. All theories of reference since Frege are based on that idea, and it just doesn't seem to be true. Although it may be true as the goal for scientific languages, which is another question. The context in which these issues usually arise is the context of analyticity, and that's just for historical reasons. First of all, because it's an interesting old philosophical notion, and second, because it's the one that Quine focused on when he was developing the theory. So the question is, a sentence is supposed to be analytic if it's true, whatever the facts may be. That's basically what it comes down to. So if some sentence is true, whatever the facts may be, it's analytic. If it's true just because of the facts. It's contingent, synthetic or something like that. And then there's a big discussion about what the meaning of this is. Now, Quine, it follows from the theories of meaning indeterminacy, and theory holism and so on, that there are no analytic statements. There are no statements. A statement that's analytic is true by virtue of the meaning. Okay, so the statement, if John is dead, then John is not alive, let's say, would be held to be analytic by virtue of the meaning of the terms, meaning you don't have to carry out an empirical inquiry into the world to find out if that's true. You know that it's true because you know what the words mean. That's the idea. But of course, if words don't have a meaning, it can't be that this sentence gets its truth value by virtue of its meaning, obviously. Okay. So one of Quine's startling conclusions back in his early articles in the late 40s was that there are no analytics. There's no difference between analytic and synthetic sentences. They're all the same. They're all epistemologically the same. Some of them may be more deeply rooted in our belief systems or something, but nothing else. Well, suppose we want to discuss, certainly that's not the way people think about it, And we could, since it's a question of fact, we could presumably carry out empirical inquiry concerning the topic, okay? We could try to find out whether, in fact, that's the way people understand sentences. Factual question, there ought to be a way to investigate it. And suppose we take let's take a slightly more complex example, the kind that's come up in the literature. Suppose I take the sentence, if John persuaded Bill to go to college, then Bill, at some point, I'll leave that out, at some point in the past, intended, or maybe decided, to go to college. Okay, take that sentence. And suppose we compare this sentence to a different one. If John persuaded Bill to go to college, then John intended or decided to go to college. Thanks. Okay? Suppose we just compare those two sentences. And we give them to a lot of speakers. And we ask them to judge which ones are true and what would you do to figure out whether they're true? And we make up experiments about that topic. And we know what we're going to find. We're going to find in the first case, where Bill intended to go to college, that overwhelmingly people say it's true and you don't have to do any investigation. To know whether John intended to go to college, well, you got to figure out whether it was true or not. The sentence doesn't tell you. Okay. We give people, let's put it this way, we give people this sentence, John persuaded Bill to go to college, and we ask them about these two sentences. We ask which one is true. If we say, suppose it's true that John persuaded Bill to go to college, give me a judgment about whether Bill intended to go to college and whether John intended to go to college. Okay, well, everybody knows that unless Bill in fact intended to go to college, John did not succeed in persuading him to go to college. But as to whether John intended to go to college, we just don't know. The sentence doesn't tell us. And we could get very reliable results showing that people distinguish the sentences that way. Well, those are facts. Facts have to be explained. How would we proceed to explain them? The way the literature works is kind of interesting. If you look, there is a debate about this in the literature. Somebody says, I think there's a meaning connection in one case and just a factual issue in the other, and somebody else comes back and says, well, that's not my intuition. My intuition is they're both factual. And then the debate stops. It's kind of like, an impasse. But it's not an impasse. I mean, if everyone agrees on the facts, and if you agree on the facts, you can consider alternative theories. Well, there are alternative theories in this case, and you can compare them on their merits. The theory that gives you the obvious result, that says that this one entails this one, is a theory which will involve notions like causation. It'll in fact say that persuade is a causative verb. It's a causative verb which has a lexical decomposition into a notion causativeness and a notion intention, so that it in effect means cause to intend, or cause to decide. And then, you know, the people look at some other language and say, yeah, it actually is spelled out like that with a causative verb and has the properties of causatives, and notions like cause and intend and agency, which enters into this, and all of these notions will appear within a theory of a semantic theory about how concepts are organized and what their connections are, and there'll be syntactic properties about causatives which will have to carry over to this and so on. That's one theory. That theory gives you the conclusion that if John persuaded Bill to go to college, then Bill intended to go to college, but nothing about whether John intended to. Now, what's the alternative theory that we're supposed to compare with this? This is a theory which says one is analytic and one isn't. What is the alternative theory that we're supposed to compare with this? Well, it's kind of interesting. The alternative theory doesn't exist. I mean, what we're told is some sentences are more deeply embedded in our belief system than others. But obviously that's not going to work here. The sentence, if John persuaded Bill to go to college, then Bill intended to go to college, is not deeply embedded in my belief system. In fact, I don't have any belief system involving that thing at all. Or if you think it is deeply embedded in my belief system, then show me your theory of belief fixation, which leads to that conclusion. What theory of belief fixation shows me that one of those two conditionals is more deeply embedded than the other? Well, there is no such theory of belief fixation. Or some other people, like, say, Paul Churchland, say that the difference is that what we call analytic sentences are more deeply involved in normal inference than others, like logic. Well, neither of these is involved in normal inference or logic, so that can't be right. In fact, we have no alternative theory. There is no alternative theory to the semantic theory, which explains the difference as an analytic synthetic difference in terms of notions like cause, intend, agency, etc. Well, we now have a funny situation. There's a fact. I mean, a class of facts, big mass of facts like this. Everybody agrees on the facts. We have one theory to explain them, a semantic theory of semantic features and so on with fixed meanings. We have no other theory, just hand-waving, belief systems or something like that. And remarkably, everybody accepts the non-theory. What has swept the field is the non-theory. The standard conclusion from these disagreements is it's been shown that there aren't any analytic sentences. That's an extraordinary case of irrationality. I mean, however good you think this theory is, at least it's a theory. And you can extend it and you can find evidence for it and so on. And it is universally assumed that it's been disproven by the statement that another theory, which I can't construct, is right. That's in fact what's happened. And therefore, it is now regarded as one of the best established conclusions of modern analytic philosophy that there are no analytic sentences, that the analytic-synthetic divide is artificial. You take a look at any textbook you like, that will be presented as one of the real discoveries of modern philosophy. Well, sort of like the bedrock for all further work. Well, what has been discovered is that if you decide to abandon the one theory that works and to claim that something else works which you can't formulate, then you get this conclusion. That's what's been found. But again, a rational, naturalistic approach would draw exactly the opposite conclusion. Of course, we haven't proven that there are analytic sentences, because in science you never prove anything. You haven't proven that space-time is curved either. You've just got evidence for it. What we've shown, however, is that there are pretty good semantic theories, just as there are pretty good phonological theories, that explain a lot of things that everyone agrees are facts, like the radical difference between these sentences. And it assigns them the different status, analytic and synthetic. So therefore, on naturalistic, rational grounds, that's what we conclude. To conclude on the basis of this that the analytic-synthetic distinction has been eliminated, or for that matter, even questioned, Even to conclude that the distinction has been questioned is totally irrational. The distinction hasn't been questioned at all. There's a perfectly good theory that predicts the distinction. There's nothing that questions it, and therefore it hasn't been questioned. Until somebody comes along with an alternative explanation of these facts, it hasn't been questioned at all. Well, again, that's a case of, in my opinion, extreme irrationality. Not in this case so much dualism as, well, maybe so, you know, an insistence that questions about language and mind and so on simply cannot be approached rationally, can't be approached by the rational requirements of the natural sciences, where if you have a fairly good theory to explain certain facts and no theory as a competitor, then the no theory is thrown out and the fairly good theory is tentatively accepted, which in this case would mean accepting the analytic-synthetic distinction as pretty well established. Let me stop.
Well, you told us that words in natural language don't refer, that perhaps terms in empirical science do, that properly speaking, speakers do that work, refer to things, natural kinds, and so on. Well, but one comment and one question. The comment. The same could be said about people working in empirical science. People working in empirical science. I think it's natural to say that scientists do refer to natural kinds by means of the terms they have in their theories. So in this respect, there wouldn't be any difference between scientific language and natural language. And second, the question, if it's speakers who refer, how is that possible? They talk about things, chairs, tables, blackboards, and so on, but how do they manage to do it? It's the answer that their mental representations refer. In that case, why externalist theories of reference are wrong? They would be applied not to words in natural language, but to words in the language of thought.
Well, I haven't really given any basis for I just said I believe words in natural language don't refer. I haven't given any basis for that yet. I'd like to come back and give a basis for it. I just wanted to indicate where I'm going. My feeling is that it's a mistake to think of words in natural language as referring. I'll later come back to why I think that. So I haven't given any reason. As to scientific language, you could say that scientists use the word atom to refer, but I think that that's probably a misdescription of the project of natural science. Now, this again, it's a topic, you know, I'd like to come back to it. But the way I understand the project of natural science, including the project of linguistics, the idea is to try to construct a symbolic system in which, in fact, the words will refer. So if a linguist is trying to construct a system with notions like cause or intend or phonological unit, wherever I had that, you're working very hard to develop a theory in which the terms themselves will pick out some real thing in the world, and you want to extract yourself as the user. I think that's just the nature of the project. Okay, well, we can talk some more about that. As to the second question, that's a deep question. That's Brentano's question. It's the question of intentionality now with a T. How can people refer to things? Well, it's a hard question. I don't think the language of thought helps at all in that. Maybe there is one, maybe there isn't. But whether there is a language of thought or not, we have the same mystery about how people can refer to things. How can I talk about this table, let's say? Now notice that when we, just to give you a feeling as to why I'm skeptical about words referring, notice that this goes back to Frege in the modern period. Notice that Frege had to make up technical terms. Bedeutung doesn't have the German meaning of bedeuten. Okay, he made up a term. And the same is true in English. In English, the word refer is not a relation between words and things. It's a relation between people and actions. So the whole terminology of Hispanics, back to Frege, is invented technical terminology because natural languages have no concepts like that, which is already suggestive that, you know, you're talking about something other than natural language. It doesn't prove it, but it suggests. But we're left with the problem of intentionality, I quite agree. I mean, we're left with asking how people refer to things. However, notice that the way we refer to things is not by picking out words that refer to them. Like I can give a talk, say, about, you know, the economic situation in Harlem, in some New York area of New York City, and I will be referring to the United States, but I may never mention the United States. Okay. I may never use the phrase United States or any similar phrase. In fact, you can refer to things in all sorts of oblique ways. If we really want to analyze the notion of referring, it's going to go very far from something that people do. The act of referring is going to go very far from specific use of words. I mean, I can be talking about a friend of mine, let's say, and never mention him at all. I'm referring to him, but I'm just talking about some property that he has, let's say. So to take an example, I talked earlier about generative phonology and structuralist phonology. In my mind, I was referring to a friend named Morris Halley, but I never mentioned it. I mean, most of the people here knew I was referring to it. Okay, but I didn't mention him. I didn't use his name or anything else. I was, of course, referring to him. And we can ask the question, how did I succeed in referring to him? Well, that's an interesting question, but it surely didn't involve using his name, because I didn't use it, or using any designation of him, because I didn't use any designation of him. I just referred to a certain debate that had taken place, in which a lot of people here know that he was one protagonist. So in that way, I was talking about him. In Brentano's sense, I was talking about him, clearly, and that's what I had in mind. If we want to add a story about how in the language of thought his name cropped up in my brain, we can do it, but I don't see that nothing has helped.
Yeah, just a clarification question. I suppose that you have answered it in a previous question. If it is not true that words refer in natural languages, what do we linguists exactly say when we talk about dependence in reference or co-reference, anaphoricity, and all these kind of things?
Well, that's a good question. It certainly is not reference. It's not reference. It's not intended reference. It's none of those things. I mean, I could talk about it. Let me come back to it. If I don't get back to it, bring it up again. I'd like to get back to it in the proper context. But whatever it is, it's surely not reference. In fact, I think, just again to give you my opinion, formal semantics, or linguistic semantics, the field of linguistic semantics, in my opinion, isn't a semantics at all. It's a form of syntax. And people are very confused about that, in my opinion. And that's true whether you bring in possible worlds, or discourse models, or mental models, or whatever. All of that stuff is no more semantics than phonology is sound waves. I mean, it's all something going on in the head. It's all completely internal. It's internalist. And if we were accurate about it, we would call it syntax. I mean, when phonologists get down to the level of phonetic form, they don't think they are talking about noises, right? There's a big step between phonetic form and noises. Okay? And there's the same big step between possible worlds and something outside the head. It's just that people working in semantics just haven't recognized that. And I think it's possible to show it. I mean, I'll come back to evidence that shows it, I think. Incidentally, I should say that my own work over the years has always been misinterpreted in this way. I mean, standardly, everybody says I do syntax, other people do semantics. The fact is, if you take a look at my earliest work, and up till today, same thing everybody else did. I'm interested in the difference in meaning between John is easy to please and John is eager to please, and all that kind of business. Or what's the difference in meaning between the two senses of flying planes or an after and so on. It's just that I call it syntax, and other people call it semantics. And that's what I think it ought to be called. I think we ought to use the term syntax for all of everything that involves just mental representations and never gets to the world. There doesn't even have to be a world. It could all be going on in the head. There might not be any world at all. We'd still do it exactly the same way.
One more question. You said that it's nonsense to say that Bohr's atom is the same or different from someone else's atom. But why? You have adopted a realist stance about studying language.
Scientific language.
Scientific language.
True. I do adopt a realistic stance about scientific language. It's the same question as before. I mean, it's a question of how we interpret the scientific project. Do we interpret the scientific project as an effort to achieve not only realism, but even a mapping of it, a symbolic mapping of reality? I do interpret it that way. That's, what's called naive realism. And, yeah, I think that's right, But I understand that one might not,
Okay, well, I wanted to make a comment that perhaps goes a little bit on the sociolinguistic side. Well, English being a kind of ethnic Greek for most of us, I think that one of the appeals, the strongest appeals of your philosophy has been to take us speakers of other languages into account. We seem to speak kind of underlying structures, of underlying layer of semantics and everything. I remember when I first studied your work, this sentence, flying planes can be dangerous, not dangerous, and then I saw that flying planes can be dangerous, can be ambiguous in English. It was a surprise for me, because in making a panic, flying planes can be dangerous if you only speak English. If you speak other languages, there are other choices. So this means that when will this variety of languages be taken into account? Because we seem to be working on the level of theaetetus, where people say, well, I understand language is Greek and no evidence is relevant. And I think this is an important point in linguistics.
Well, it's certainly not. I mean, it does. See, again, to ask whether flying planes is dangerous, can be dangerous, is ambiguous in Catalan, doesn't mean anything, because the sentence "flying planes can be dangerous" doesn't exist in Catalan. The sentence "flying planes can be dangerous" is a certain collection of phonetic and semantic and structural properties, and that collection of properties happens to be generated by the so-called English I languages, and that collection of properties isn't generated by the Catalan I languages. They generate other things. Now, we could ask whether there's some counterpart to them, and that's always a matter of more or less. That's a matter of whether two people. It's like asking, do two people look alike? Yeah, somehow. No, it's a question of choice. The comparison of an expression in one language and a comparison in another language is not a matter of truth. It's a matter of decision. That's why translation is an art. Because you have to make the decision in a way that is aesthetically as well correct as well as other ways. It's not a mechanical procedure. There's no such thing. But as to looking at other languages, I don't exactly see the question there.
I would like perhaps you take a book like Analysis of Mind, Trials. Well, that's an excellent book about the English language.
Which book?
Concept of Mind by
Ryle.
Right. Book, if
I think it's a bad book about the English language.
It's okay. But then you can even translate the title into other languages. It takes a lot of energy, whether you choose etc. You take Quine's book, an excellent book, and until you get at page, I think, 49, where he says, from now on I will be rather parochial. And actually he gets very parochial. And this happens, I have been checking several books, and there's a transition between speaking about language to speaking about English. English becomes the language.
That's absolutely not true. That's just like saying that biology is parochial because it talks about Drosophila and E. coli, and it doesn't talk about giraffes and rabbits. I mean, but biology talks about Drosophila, E. coli, nematodes, and so on. Well, why? Because those are the things that enable you to discover something. Now, like when I'm doing linguistics, English is what allows me to discover something. When Carmen Picaya is doing linguistics, Catalan is what enables her to discover something, or English in her case. And people study what enables you to discover something. But linguistics is no more English-oriented than any other language-oriented. In fact, the first large-scale generative grammar was on Hidatsa, and the first generative phonology was on Hebrew. I mean, it came to be English-centered, if you like, only by a historical accident. A lot of the early work happened to be done in the United States. So, you use English instead of, Swahili. But by now, probably the richest work is done in the Romance and Germanic languages, because that's where most of the people are, and that's where, I just came from Norway, from the Germanic Linguistics Conference, and of course everybody's talking about details of Icelandic and how the two dialects of Swedish differ and so on and so forth, because that's the material that, and in fact that's the right materials to look at today, like Drosophila is right for biology, are probably not English, but Romance and Germanic. And the reason is that Romance and Germanic offer opportunities that English doesn't offer. English happens, for all kind of reasons, to be kind of isolated. I mean, it's isolated in part because the English settlers were genocidal maniacs, so they just murdered everybody who was in the way. So in the English-speaking areas, what's left is a very uniform thing. And first they wiped out the Celtic periphery, and then they wiped out everybody in North America and so on. So what's left in the English-speaking areas happens to be quite homogeneous, for historical reasons. The Romance languages and the Germanic languages, it's not that they were less genocidal, they weren't as powerful. So therefore they couldn't wipe out everybody in the way. I mean, they tried, like the Germans tried and so on, but they never got around to it. And so what's left is a variety of, there's a tremendous variety of closely related languages throughout the Romance and Germanic areas. And those slight differences give you very interesting tests for linguistic principles of a kind that you can't find in the English-speaking areas. And that's why the focus of linguistic work, advanced linguistic work, has in many ways shifted to the Romance and Germanic areas. But that's like, that's just the fact that science is opportunistic. You look at the places where you can learn something. And the places where you can learn most now are probably Romance and Germanic. So, people who are in those fields are lucky. There happen to be, they're like biologists who work on E. coli. They're lucky. They're looking at the thing that matters. But English-centered doesn't make any sense. That's just a historical accident. Like, I only speak English. Okay, it was English-centered.
This is a point about use of formal languages in grammar. And what I would like to suggest is when formal languages are being used in grammar, in certain kinds of formal grammar, it's not a treatment of natural language as a formal language, it's just use of formal languages in mathematics as a tool to describe properties, semantic properties, phonetic properties.
When by formal languages, do you mean things like Montague grammar or something like that?
Yes.
Montague grammar is a kind of syntax, and it has to be evaluated on its merits, like other kinds of syntax. Like various theories of phonology and so on. I mean, maybe it has merits, maybe it doesn't, but you have to look at it on its merits. It's not any more, I mean, to say that it's formal is kind of funny. You can formalize anything. I mean, anybody who's taken a course in first-term logic knows how to formalize anything. It's kind of surprising that, I mean, it's worth noticing that in the sciences, nothing ever gets formalized. I mean, about the only field where anything ever gets formalized is linguistics. And people in linguistics think it's really important to formalize everything. It's very curious. You know, I mean, nobody formalizes biology, let's say. Actually, to be precise, in the sort of worst moments of logical positivism, there was an attempt to formalize biology. There's actually a book by Woodyard which formalizes biology. I mean, no biologist ever paid the slightest attention to it. Physics is mostly non-formalized. I mean, the parts of physics that are formalized are the kind that are the part that, say, use particular mathematical models. Like if a guy's using gauge theory, okay, it'll be formalized. Mathematics wasn't formalized until quite recently. In fact, if you look at the history of mathematics, not only was it not formalized, but it was just ridden through with contradictions. I mean, Bishop Berkeley, for example, found straight contradictions in Newton. Newton was mainly a mathematician, and he found contradictions. I mean, he found proofs, and he was right. You know, he found proofs where Newton, crucial proofs, where Newton would refer to zero in one line as meaning zero, and then down in some other line he would use zero as referring to something arbitrarily small, what we would now describe as a function converging to zero. And those are different things. But he was using them interchangeably, so that's just a contradiction. And he found all sorts of contradictions. I was
talking about an example. Say, the notion of entailment. If you want to define the notion of entailment.
Sorry?
If you want to define the notion of entailment.
Define the notion?
Entailment. Entailment.
Entailment, yeah.
Then, okay, to do that using existing tools, we look to mathematics, we look to model theory, say. And
we may if we feel like it. I doubt that very much. For example, this is a case of entailment.
Yeah.
And I don't think we need the formalism of model theory to explain it. We could explain it in the formalism of model theory, but it's so trivial, it's hardly worth it. The point that I was getting at is that in the natural sciences, formalization is like experimentation. You do it when you need it. You don't bother with it when you don't need it. You know, I mentioned before, you don't do more careful experiments than you need, and you don't do more formalization than you need. I mean, you should have your ideas at a point where they could be formalized by known means, but you don't bother doing it. You don't do it in mathematics, you don't do it in physics, there's no reason why you should do it in linguistics. And as I was getting at before, mathematics, which is after all the sharpest discipline, was perfectly happy to live with contradictions for years. I mean, mathematics got formalized at the point where you couldn't make progress without formalization. So there came a point where thinking about, you know, a limit as something just very small didn't work anymore. You needed a notion of limit. So then it got formalized. You know, you get Cauchy, Weierstrass, and so on. But up till that point, it didn't get formalized because formalization is a total waste of time. It's a triviality that any child can carry out once they've studied the first semester of logic. But it's a total waste of time, which is why nobody bothers with it.
So if we look at work done on semantics and formal semantics, these people, I mean, the questions they're tackling are not trivial, long papers.
Sometimes there are non-trivial things.
Is it somehow premature to work on these questions? Or?
There's no general answer. I mean, there is work on, say, some of the work on generalized quantifiers probably requires formalization. I think that's true. I mean, there's nothing wrong with formalizing when it's needed. If it can give you some insight, fine. If you don't need it to give you insight, fine. But, you know, to insist on formalization as something that you ought to do makes no sense. I mean, if that were the case, we'd throw out mathematics. If you took the latest issue of the American Journal of Mathematics and tried to formalize the proofs that are given there, it would be a horrifying job. In fact, it might take volumes for every article because of the amount of tacit assumptions and intuitive leaps and so on and so forth. And in fact, up until the 19th century, there was literally no way of doing it. It's a curious thing in linguistics. There's a big demand in linguistics for formalization, and a lot of things are criticized because they haven't been formalized. That's kind of like Bishop Berkeley. It's not even that far. It's not people have found contradictions. Berkeley actually found contradictions. Actually, it's historically sort of interesting to see what the reaction was to that. There were known problems in the classical analysis, what we call calculus. Some of them were straight contradictions. Some were just obscurities, like the notion of converging to a limit, which is extremely obscure. I mean, when most of us study, high school mathematics, and you're taught that things get arbitrarily small, it's a very obscure idea. I remember when I was a student, I didn't understand it at all. But most of modern mathematics was developed before that stuff was understood, and it's interesting to see how. There was an early split between British and continental mathematics on this issue. The British mathematicians, by and large, took the problems very seriously. They were worried about the contradictions, they were worried about the unclarities, and they tried to formalize. The continental mathematicians, like Euler and Gauss and the rest of them, just didn't care about it. They said, let's just do the mathematics and forget about the formalization. Okay, someday it'll get formalized. Let's just do it, and we'll worry about the problems later. Well, what happened is that continental mathematics was very productive. In fact, though Newton invented the calculus, almost all the work was done on the continent in the next couple of centuries. British mathematics was, by and large, pretty barren. And the reason was they were trying to do premature formalization. I mean, at that stage of mathematics, it didn't matter if you didn't understand what you were talking about. It was worth just doing it intuitively and using your intuitive concepts of space or whatever anybody was using. And that's where the productive mathematics came from. Later on, you formalize it. I mean, I've heard theoretical physicists say they don't care if their integrals don't converge. Somebody will worry about it some other day. Now they just want to work on the problems. And there's no reason to think that linguistics is more advanced than classical analysis. Very little. In fact, it's much more primitive. So the idea that it's somehow important to do formalization in this, small emerging discipline, when it isn't done in the most formal sciences, seems very weird. If, in fact, doing it gets you somewhere, okay.
I think this formalization is not really analogous to trying to give a foundation to mathematics. It's just using mathematical tools.
But if you can use mathematical tools, first of all, it's very doubtful that you can. First of all, it's not true that they're using mathematical tools. I mean, the amount of mathematics that is used in, say, Montague grammar is about zero. I mean, Montague grammar sometimes it's called a branch of mathematics. In fact, Rich Thomason, in his introductory book on Montague grammar, starts by saying, look, this is not an empirical study. It's a branch of mathematics. Well, in a sense, that's correct, but it's a very odd branch of mathematics. For example, it's the only branch of mathematics that doesn't have a single theorem in it. In fact, doesn't even have an imaginable theorem. What kind of mathematics is that? I mean, this is playing around with symbols. That's not mathematics. So mathematics is an effort to discover truths. To discover truths, that means to prove theorems, interesting theorems. Have you ever heard of a theorem in Montague grammar?
No, I think it's just a tool for defining entailment.
Well, yeah, but we know how to define entailment. Everybody who has studied elementary logic knows how to define entailment. If you want to bother defining it, okay. I mean, it's like, it's like requiring of a physicist that they present their paper going back to the axioms of Zermelo-Fraenkel set theory. I mean, yeah, sort of, they know it can be done probably, but they're not going to bother. And if there's some special reason to bother in this case, one would like to know why. I mean, look, I gave an argument about entailment. Everybody could follow it. Would that argument have been improved if I had filled blackboard after blackboard with model theory. It would be the same argument. And in fact, everybody knows how to do it, more or less, if you have to. You know. Now, if formalization turns out to get you somewhere, fine, just like experimentation. I remember once a rather famous French mathematician, some of you may know, told me, who also works in applied mathematics, once told me that he thought the most elegant physics was the physics that used the least mathematics. You know, I mean, you just used exactly as much as you had to use. You didn't use any more than you were forced to use, and that's probably right. You know.